Hello and welcome to IoT Builders, a live stream where we discuss a range of topics on the Internet of Things, from embedded devices to cloud services, all from an IoT builder perspective. It is March 1st, and this is episode 19 of our weekly live stream. And today we have two special guests, Stefano Marzani and Robert Day. Stefano is a technical leader for SDV at AWS and SOFI governing body member. We will see what SDV and SOFI means a bit later. And then we also have Robert, who is a director for autonomous vehicles at ARM and also a SOFI governing body member. My name is Nenad Ilic. I'm a senior developer advocate for AWS IoT. And I'm joined with my colleague and co-host, Dan. So hi there. How is it going?
Hey there, Nenad. Good. Things are going well. Thanks for hosting the session today.
Yeah, no, thanks you for coming and helping out. So let me add Stefano and Robert. So hi guys, how's it going?
Going well. Hi, Nenad. Hi, Dan. Stefano here. Pleasure being here. So going very well. Thank you.
Yeah, and same. Really appreciate the opportunity to come along and chat.
Excellent. So do you guys mind introducing yourself and tell us about what you have been doing so far?
Robert, you want to go first?
Sure. Thanks, Stefano. Yeah, my name's Robert Day. I'm based in California, and I work in ARM's automotive division. I've spent a lot of my time looking at the needs surrounding autonomy, but also I've been very much involved in the SOFI initiative, which you'll hear a little bit more on later in the show.
Yeah, and here is Stefano. I also live in California, in Mountain View. I'm the tech leader, as you said, for SDV in AWS, in our automotive and manufacturing business unit. Before that, I worked on autonomous driving quite a lot. So for at least 4 years, developing autonomous driving stacks and managing tools, workflows around autonomous driving. But yeah, right now I just went to this exciting new thing about automotive, that is software-defined vehicles. So just taking some of the learnings that I had during building up autonomous driving stacks and applying them in how you should create software for automotive and how we can innovate in there.
No, excellent. Yeah, thanks guys for coming over on the show. So maybe we can start with this because you already mentioned like software-defined vehicles. What does actually that mean, and then why does it matter at all?
I can start with that because we think about it pretty much in AWS about what SDV is, right? And we are customer centric. So SDV is what SDV is for our customers. So jokes apart, there are many different definitions of SDV. For sure, software-defined vehicle is a vehicle, right? It's a vehicle where the functionalities can be updated, secured, personalized throughout its lifetime. You know that traditionally it's been very difficult to keep software updated in vehicles, given some structural issues with their onboard networking and for historical reasons. But SDV is exactly that. And if you go at the core of it, is really decoupling the software development from the hardware platforms, or like you do in smartphones, right? And frequently we refer to cars, modern cars, as smartphone on wheels or data centers on wheels, right? And that's exactly why, because you want to create software for these platforms, not having a hardware on your desk or a car that you need to tap into to do the development, because it's custom development for a specific platform. So this is the first layer of definition of SDV. There's another part that's very interesting as well. That is, it's in SDV we have, of course, this application and software development part, but we have a data loop as well. So data, and frequently in the sector we talk about this big data loop. After a very nice blog post from Porsche Engineering in 2021, right? They did a very nice blog post talking about it. But all the insights that are generated through this data play, right? This data big loop can be used, of course, to improve current functionalities, but even to, let's say, create or optimize the next generation vehicles. So software-defined vehicle in that sense, right? So updating the current software functionality in vehicles or designing new features, new components, and optimized platform for the next generation vehicle, even in the mechanical terms of it. So as you see, there's a word behind this overloaded term right now.
Yeah, it's very interesting as well that you can see the benefits of the software-defined vehicle for both the consumers, i.e. the people that buy vehicles, but also the automotive manufacturers that sell the vehicles. So from a consumer perspective, we're used to, because of our smartphones, we're used to having constant updates, and your phone gets essentially better over time because of the software updates that you get. Anyone's got a smartphone, you wait for the next operating system update, and all of a sudden you get a bunch of new features, or you update one of the apps and all of a sudden it does something that it wasn't doing before. There's no reason the car shouldn't be like that too. And so as consumers, we're kind of expecting that our car gets better over time, not worse. And at the moment, as Steph said, it's difficult for the dealer infrastructure to be able to kind of keep up with this. And so what this means is the consumers are going to have a different relationship with the automakers. They'll have more of a direct relationship. So the automakers will push new features or updates that the customers can kind of take over the air. And then there'll be a new feature. This is potentially even, monetization of this. It's like, hey, I can make your car better with this extra feature that you didn't have when you first got the vehicle. And so the automakers are looking at this going, whoa, this is kind of cool. I get to keep the relationship with my, the person that bought the car as they continue to use the car. And I get the opportunity to kind of give them new things. There's also the opportunity potentially to, have a base vehicle that the trim level is based on the software side of things. So you could have like the elite model has more software features, more functions within the vehicle, a better infotainment system or whatever, as well as then the updates to features that you get when you first buy the vehicle. So for example, a lot of the ADAS functionality that's in a car right now, so advanced driver assistance system, so things like automatic braking and lane keeping and things like that, a lot of that's being defined by software. If you've got all the sensors, it's really a software function that will give you an additional ADAS functionality or a more accurate or a better view of the mapping. And so the relationship and the automotive manufacturers can see this as an opportunity to provide more new features to their customers.
Mm-hmm. No, this is great. I remember this examples when we talked. Is like with having some kind of optimization in terms of like your battery performance. So those engineers have different models. They're doing it, for example, in MATLAB and whatever. And then suddenly they realize that with a certain software update, they can increase the efficiency of a car by like 5 or 10%. But if the infrastructure is not there for the software-defined vehicle where they can verify this and then distribute the software directly, as you mentioned, then it's really going to be hard for the end customer to get that benefit, right? So yeah, this is how I also see it based on what you were describing. Is like a software-defined vehicle is like you have that infrastructure to even allow the updates to come afterwards, as you said, like new features, increase efficiency and so forth. So that really, to be quite honest, like that is really exciting for me, coming from like an IoT and also automotive perspective. So that's pretty cool.
It's really cool. It's so just to tell you personally, I think this is the most transformative moment for the auto industry since the Ford Model T. And I'm not joking, because again, it's not just SDV. It's electrification. It's the fact that consumers need sophisticated experience in their vehicles and the connected experiences, safety. We are at the brink of a vehicle that can go autonomously on roads. So it's really a huge transformation that is coming for the product, right? So it's super exciting moment for automotive. Super exciting.
Yeah, and I can
Yeah,
think of
so-
this. Yeah, go on. Sorry.
Sorry, so I was just about to say. So, Steph, you sort of touched on something that's interesting there. What we're seeing with the, the move to electrification, is that auto manufacturers are now going, "Ooh, I can really redesign what my car looks like. I'm not just going to take an existing car and stick an electric motor in anymore. They're really looking at building EV platforms, and those EV platforms are then they can develop these to be software defined. That's the beauty. It's like you're not trying to necessarily retrofit this. You're actually building a whole new architecture for vehicles.
Yeah, and you see that even aesthetically. I don't know if you like me, I'm very passionate about cars, right? And if you see the new generation of electric vehicle, and you see, let's say, the current generation of other vehicles, right? You really see the aesthetics different, right? So and that's really interesting. But even some of the basic functionalities, because when you have a platform, electric platform, everything changes. The volumes of the car, the performance range, the parameters are completely different, and the architecture is completely different even from the electronic perspective. So it's another product.
Yeah, you do see a big difference between, some of the newer EVs coming out, and some of the, kind of more legacy brands, things like that. And I think you see the difference in the customer appreciation of some of those features, right? I think we've seen evidence that this is actually what customers want, because it's bringing a lot more delight to the experience, and I don't think people are asking for less features going forward, right?
Yeah, that will never happen. No, yeah. So go on. Son.
Yeah, absolutely.
Yeah, it's interesting to see this. Like I like to build up on what Robert said in terms of we will probably see this kind of like a plain a chassis, more or less, or like a baseline car that's coming out, which includes all the functionality, um, more or less, and then on top of this, like you can build and customize your own type of car. So with kind of like unlocking this with this SDV as well, right? That is also pretty exciting. But
Yeah,
yeah, go on.
Go ahead. Then.
No, I wanted to ask about, you also guys mentioned Sophie. So now, like when we see that vision of like SDV and how it could look like in the future, let's say, not maybe near future, there is still a lot things to be done, right? And there needs to be kind of like a common platform, something that those functional, like the infrastructure that this can be built on top. And I know you talked about Sophie, and I remember you were mentioning about this, that it's basically aiming to be that infrastructure. Can you guys talk about that as well?
Yeah, I'll have Robert taking that. So we're just coming from a Sophie meeting, by the way, right before this show. But there are two things that are really fundamental, in my opinion, that needs to happen: consolidation of electronic architecture. And Robert wrote a very nice blog post about it, about consolidating and why you need compute, right, that is powerful enough to support this kind of functionality, and standardization, and creation of these layers of standardization that you need to use to describe your workers and distribute them, right? So it's simple like that. But Robert, I'm sure you have more context and details about it.
Thanks, Steph. So what's interesting is everything's sort of shifting as we move towards this, software-defined vehicle. Things have to change in how automotive software development is done. You've got this idea that a lot of the functions in the car are going to be driven by software. They're going to be updatable, upgradable, customizable, whatever you want to say. And so your development paradigm, it has to be a lot more agile. You can't kind of just rely on, here's my electronic control unit and I've got some software for it. There you go. That's a box. Off you go. The whole compute architecture is going to change, and we can talk a little bit about this later on. But the software development has to change. And that's where what we really did when we sort of started looking at the requirements, and we formed Sophie about sort of 18 months ago, was really looking at, well, we shouldn't have to reinvent this wheel, excuse the pun. We should be able to look at some of the the software development practices that are out there and just apply them to automotive. And that's what we really did with Sophie. We took a lot of the development methodologies that are in cloud development, but instead of targeting a cloud instance for your software, you target a vehicle. But your whole development can be done in the same way, can be done in the cloud. And then when you're ready, you basically, orchestrate it over to the vehicle, or to the vehicle hardware. And so this gives you you can take a lot of the standards that are out there right now, a lot of the ways that people develop software in an agile way, and apply it to your vehicle. Now, what this is actually also doing is something that's termed shift left. So at the moment, the automotive development process is sort of sequential. You kind of start building your electronic control unit, you start building your software, you test your software, you put it in your vehicle, somebody buys the vehicle. And that's sort of it. What we're looking at now is developing that software much earlier on in the process, because there's a lot more of it. And so actually shifting left means bringing that start of development a lot earlier, not waiting for your ECU to be available. And that's where using the cloud and doing cloud development and basically starting your software development in the cloud in parallel to as you're developing your hardware that's going to go in your vehicle. And then so when you're ready, your software is pretty much ready to go, and it's more an integration and a testing in the vehicle itself, rather than this sort of sequential thing there is now. It also gives you the opportunity to continue that development once the vehicle has left the dealership. And so it's really shifting the paradigm, and that's what Sophie is really trying to do. It's defining an architecture based around existing standards that are used for cloud development, but applying them to a vehicle, because a car system is different to a cloud. Even though we have the term data center on wheels, there's a lot of stuff that goes on in a car that doesn't go on in a data center. Safety, real-time performance, all that sort of stuff we have to worry about in vehicle development. And so we have to, part of what we're doing with Sophie is looking at what do we need to do with these existing cloud standards and tooling, and make them applicable for vehicle development or vehicle software development.
Yeah, and when you think about system design, a lot of it is about components being integrated, and software systems have been doing that for some time. The CI part of CI/CD pipeline, right, is continuous integration, and so you're always doing those integrations with software components. And maybe historically with vehicles, these components have stayed relatively independent of each other, of course connected by things like CAN bus and so forth. But do you see that as the shift, as really looking at it as a system as a whole, and having these sort of pre-integrated parts?
Yeah, so that's a really interesting point, Dan. So we're the architecture, the EE architecture in a vehicle is changing, and some of this it's changing as we are looking at how vehicles, the systems in a vehicle get connected together. Because one of the real issues is all the wiring for all these different compute systems all connected together is expensive, it's heavy, blah blah blah. So finding a better way of actually bringing these things together. So what's happening is there's a consolidation at the moment. Historically, vehicles have got a lot of compute boxes called ECUs, electronic control units, and those do a particular function, and they've got particular hardware and particular software that does that particular function. And you're right, they communicate with each other on something like a CAN bus. What we're seeing now is they're being consolidated down into what are called domain or domain controllers. So you'd have, for example, an infotainment domain or cockpit domain, or you'd have an ADAS domain. And so you have a bigger box which consolidates a bunch of features which would normally be done on an ECU with bigger compute. And then the software is what really kind of defines how this works. So that's sort of this domain controller where each domain has its own big compute or bigger compute to do a lot of the functions. what we're seeing in the future, or kind of starting to happen now, is having an even bigger compute or a central compute that basically runs pretty much all of the software functions for the different domains on one box. So you're moving from domain controller. And this actually brings a term called zonal controllers in, where each zone of a car, or, back left, back right, basically all of the sensors, like your cameras or your lidars or radars, or whatever, they all kind of feed into that zonal controller, and then it spits the information to the central compute that does the software defined functions. And so that's kind of the next architecture, is going to be zonal plus central, which again, we're kind of moving to more of that performance like a data center on wheels. So that big central compute has got to have a lot of performance because it's running a lot of software. And as you think about higher levels of driver assistance or autonomy coming in, or wall-to-wall cockpit displays, and all that sort of stuff, that takes a lot more compute and a lot more software. So we're seeing this shift in vehicle architecture. Some of it's sort of being driven by software-defined functions. Some of it's just enabling software-defined functions in a car.
That's really interesting because, yeah, you can see how some of the logical separation makes sense. You don't necessarily want some of the, core functions of the vehicle really being mixed with the maybe infotainment aspects of the vehicle, that kind of thing. But that's also a safety aspect to it, right? You mentioned data center on wheels. It's almost like in data centers you have firewalls so that certain things can't talk to other things.
Yeah.
Similarly, right, in the vehicle now, this data center on wheels has firewalls, right? Essentially.
And without going too deep into the technology that will enable that, the same thing for the vehicle. So having these, potential virtual domains, using hypervisors and virtualization, having things like safety islands which are a separate system to run your safety functions on. All of this technology is kind of being encapsulated in what we're doing with the SOFI architecture to try and enable that, that getting your vehicle software, but doing it so it's still safe and your vehicle still functions as a vehicle without necessarily having to have all of these separate boxes we have right now.
Yeah, absolutely. And I think it's the other important part in all of it is the software counterpart, right? As you said, the CI/CD, the CI/CD pipelines, CI/CD in this case, we have verification, validation. It's a big thing in automotive. But it's very, very important as well to, as we say, break up the monolith of the software, of the automotive software in general. Because when we think about software, and people in automotive thinks about software, traditionally in the sector you had new feature, new electronic control unit, right? So new box that you need to integrate in the car. That's why modern cars, you have, think about it, more than 70 ECUs that on multiple kind of networks and different kind of networks. Wow. It's a lot. How can you test? How can you manage, right? So, and when we say that is, okay, think about Amazon.com. It's not a monolithic software. Obviously, it's not. It's a collection, a huge amount of microservices, APIs, right? Where each functionality is implemented in API. One for, browsing the products, searching, one for the payment, one for looking up a specific vendor, and so on, right? And this bringing this kind of microservice-based approach, right, to automotive is really, really relevant. And the big part of SOFI, that's why, for example, SOFI talks about usage of containers, right, as a way to distribute software, maybe not for everything, but in a significant part. And the way you orchestrate containers, right, so really to create this modularization of the software and the re-architecting really part of the software that needs to be deployed, developed and deployed, tested and deployed in the car, right? So that's a super important part. Another parallel, think about these consolidated computers that Robert was talking about. Consolidated computer means you have multiple cores. Modern consolidated computers have more than 10 cores, right? So do you assign all of them to an OS? Obviously not. You have at least 2, 3, 4 different OSs on a single consolidated computer. Some of them real time, and some others are just Linux or open source. But you have a coexistence, and everything is managed through an hypervisor that is deployed on top of these consolidated computers. But think about it. Isn't that the same thing we do in cloud, where we have, thinking about an ARM processor, Graviton, that is an ARM-based, processor that we have in our data centers. And that's the 64 cores. And we have our Nitro hypervisor partitioning the 64 cores to different OSs, and different OSs host different microservices for different purposes. So this kind of architecting systems is flowing down inside the cars. This is the big chunk of the transformation that we need really to help out.
Yeah, I also remember seeing like this picture of different iteration cycles when it comes to like shipping new features. And then there was like, for the automotive, like there was a mechanical engineering, which is measured in years, many years, electrical engineering, which is again measured in years, but less than mechanical, let's say. And then the safety critical part is also kind of like reducing. And then you have like low level embedded software, which is measured, or actually hardware, which is measured in like 6 months iteration cycles. And then you have like hardware, which is, in months. And then you have like software, which is the end of this. It's like measured in weeks, right? So imagine that having that kind of like iteration cycle, which people are used to in weeks, and then brought to the car, like how much that could benefit the end customer throughout that decoupling, as you mentioned it, with kind of like microservice architecture, which you can focus on specific things and then go through the testing, even the functional testing, and then deploy it and then have it at the end customer. It's like amazing.
Yeah, one interesting thought is if you're thinking about the compute system in a car being upgradable and adding extra functions, does that then mean that you kind of over provision when you first design this thing, because you don't necessarily know what features you're going to add going forward? That's a very different view for the automotive world.
Yes.
To put more compute
Yes.
in than's necessarily needed, but that's the only way they're going to be able to upsell new functions if there's enough compute to actually work those functions. So it might be that the base model, for example, isn't using anywhere near all of the compute that's on there, but the premium is getting closer to it. And then there's still, options for adding stuff later.
Yeah, that is an excellent point. Yeah.
Yeah, that's a really interesting point. But if you go back to the data center model, the same thing's happening there, right? Where you don't, when you deploy a data center, you don't actually know what applications and web services are going to be running there, and it's part of the provisioning of those services to sort of allocate the right resources through virtualization, as we were talking about. And so that's where virtualization with containers and hypervisors and things like that helps you scale to the hardware that's been deployed.
The interesting story, I mean, how this came to be is like we have Christmas to blame. I mean, I'm talking from the Amazon perspective, right? Because near the Christmas day or a Prime Day, but Christmas usually, you had like those huge spikes of customers coming in and then going shopping and so forth. And when you're designing your data center, and I'm going to bring that back to you, Robert, just to see your thoughts on this. But when you're designing the data center, you have to accommodate for those spikes and then basically design it in that way. And then throughout the year, you are not running on full capacity. So I don't know Do we need a mentality shift in terms of like how we are designing cars in the future based on this? Or?
Yeah, so maybe it's interesting, isn't it? Because there have been recent discussions about upselling features for particular instances. I.e., do I need more range now because I'm going on vacation? Well, I'll pay for that. Or it's cold. Do I need my heated seats where I don't need them in summer? And so having that ability to have different features depending on what you're doing at a particular time, what your lifestyle is. That's one of the benefits software defined can bring to you. But
Yeah.
it does mean that you then have who's going to be using what and when. If it's down to the consumer, well,
Yeah.
how do you decide what that looks like? The other thing is, who's going to be providing all the software that goes into a vehicle? Thinking about how many hundreds of millions of lines of code is going to go into a high-end vehicle, especially as it gets more autonomous features. That's a big job for each of the OEMs to do. And so I think they're going to be looking at, well, I don't want to do all of this stuff. So maybe I have, trusted, third parties or, traditional tier ones that will do these software functions for me. But then what if the consumer says, well, I'd like to have something that you don't provide as the OEM, a bit like, the App Store. Okay, how do you kind of think about that going forward? What the consumers might want in 3 years' time that's not even on your roadmap as an OEM?
Yeah. No, this is exactly the point. Is like, how do you unlock and build out the infrastructure so whoever has an idea that might benefit, other people can actually implement and then have it available. That is something that we've seen with like iPhone and now Android and so forth. Which people are creative, and if you allow them and provide them with tooling, they will come up with amazing things, right? So why don't OEMs have been in this regards like more or less closed, even though they were working with some partners and so forth. But I'm looking for the future when this is unlocked, so actually other people can contribute to the overall car experience. So that sounds really cool.
Yeah, and we do not have to forget one of the main, things that are happening in automotive, and not only, but in cars for sure. That is artificial intelligence. And that, it's in the car. Of course, everything is autonomous driving, and ADAS is related to artificial intelligence. The way you give these cars and vehicles in general intelligence to, let's say, move autonomously, avoid dangerous situations. I always say, people tend to think about autonomous driving, but even with ADAS functionality, we are saving lives, right? So literally saving lives and avoid dangerous situations. So this is super important. The number of, we did an episode of All Things Automotive where we're discussing about, unfortunately, still the very high number of, car crashes and fatalities on the roads still nowadays, right? And, artificial intelligence that can really help in this situation. But again, and this is just one example, but there will be multiple artificial intelligence in the car, right? So something that, for example, can help you to manage your schedule, manage your trip, something that assists you during your drive. And again, ADAS related and so on. How do you manage all of this if you don't have a software distribution model that can feeds this and updates them, right? Again, it's a big loop. It's a connected big loop where all this content is continuously updated, right? And updated at the core of functionality. Robert is right, because there's a huge difference about an infotainment application. Okay, it crashes, fine. But you can't have any artificial intelligence driving the actuators of the car itself crashing while you are on a highway, right? So there are different criticality levels in this artificial intelligence, in these software processes that needs to be taken into account. And that's why SOFI exists, to help in defining and specifying all this kind of stuff. But it's really, really relevant. To give you an example on how much it's advanced, this sector, very recently we presented in another episode of All Things Automotive, this Alexa providing a test drive, not a virtual one, a physical test drive to a user, because you were in COVID times, right? So they thought, okay, maybe a person is not comfortable to have another person while testing a car. So why can't we have Alexa delivering this kind of experience?
Nice.
And the experience is delightful. And by the way, it's not just related to the car. Think about the whole thing that we're explaining even at CES this year, right? You're watching something in your TV during, I don't know, Super Bowl or whatever event, right? And you see a commercial of a car, and you can ask Alexa, okay, what's the range of this car that I'm seeing here right now? And Alexa can tell you, oh, it's 250 miles. And then you go and say, oh, interesting. Can I just maybe have a test drive of it? Oh, yeah, Alexa can respond saying, yeah, I can organize it into your nearest dealer. And then you go to the dealer and you have Alexa ready to welcome you inside the vehicle and explaining from the inside of the vehicle, you know, what's, you asked me for the range while you were watching the sports show. You see that indicator on the cluster, that's exactly 230 that I told you out of 250. So you think how these experiences are becoming connected. So that's why, for example, I'd like to talk about software-defined experiences rather than a specific vehicle or object. And isn't that IoT, by the way? And then it's full IoT, full power IoT. That's what it is.
Yeah, we had these discussions in our previous IoT builders. Is like, IoT is just more or less a buzzword. Because it's not about IoT in general. It is about the things. And one of the things in this situation is a car, right? And what IoT allows you is kind of building that infrastructure and connectivity, which is basically coupled, what you guys were mentioning with Sophie. So yeah, IoT should be not visible to the end user, and it should be an enabler rather than just thinking about buying an IoT or something like that. We talked about this many times.
Absolutely. The same way SDV is not something you can buy, it's an enabler. Absolutely. Yes. And they see the bundle of software definition and IoT like a very powerful one, but it's an enabler.
So one trend which is going to become an interesting, what's the functionality of my car, is as you get to that higher level of autonomy. So when you cease being a driver and you become a passenger, what does your car need to look like? Because you probably don't want to be looking at a speedo. You want to be entertained, or you want to be doing something else. So your car suddenly transforms from being a car to a bit like you're sitting in an airplane. You want to be entertained on your car journey. And especially when you get these vehicles that are going to be absolutely, no driver, no steering wheel, no pedals, no nothing. It's a different experience, and software is going to drive a lot of that. So I think back to Steph and I's kind of background of autonomy, we kind of like thinking about, well, what does that mean? What does that mean for the architecture of the vehicle? What does it mean for software development? What does it mean if you've got a ride sharing thing? So each passenger wants to have a different experience. What does that look like? And it's all software defined.
Yeah. I see a car as an extension of my living room or a playroom, and in that scenarios, right? It's like, I would like to go in a car and then, just watch a movie or play a game or something like that, and then at some point be at the specific location, right? And that's it. So yeah.
Right. Yeah. It becomes more like a plane experience than it does a car experience. Yes. As an analogy.
Yeah, definitely.
Yeah, I think the ride sharing topic you brought up, Robert, is really interesting, because that adds a certain complexity to the model of software too, where you don't have an inherent identity with the operator or the owner, right? Where it's almost like a hotel room where it could be anybody. So when you say Alexa, like who is saying Alexa, and what is that context, right? And so that gets really complicated, I think, with software. Is that something that you're looking at too? The vehicle as a shared a shared environment.
It's all part of it. It depends who's building these and for what purpose. The thing I find interesting, Dan, is if you are using these ride sharing now, whether that's car sharing or ride sharing, okay. you want the car to have the personality that you want every time you get in it. So
Mhm.
it means that the car basically knows it's coming to pick you up. So say it's autonomous, it's coming to pick you up. It goes, oh, this is what Robert wants. He wants to have this application. He wants to have this. This is the way he wants the car to look when he gets in it. And that all happens automatically. And that, again, is just updating the software in the vehicle to meet the consumer's actual preferences. It's just doing it, every time there's a new rider.
Yeah. It's yeah, back to the hotel analogy. You're seeing that in hotels now where you check in, you go into the hotel and it says, "Hello, Dan," on the TV. And whether that's, truly personal experience, whatever, at least there's a recognition that this identity has changed from the previous, occupant of that hotel room, right?
Yeah.
But then does that mean that the car would be then an extension of the cloud, or like how will that play work? Like, cloud as we know at the data center and the edge, which are the vehicles and so forth. Like, how will that look like
Yeah.
in the cloud native approach?
It has to be connected, obviously, because that data has to come from somewhere as to who the heck you are, and then I need to download what it is you want. So that's going to be cloud connectivity. We tend with Sophie to talk about the development of those applications, but
Yeah.
obviously there's a whole other infrastructure which is actually just deploying and personalizing those when the vehicle's on the road.
Yeah, but what you mentioned, first of all, the infrastructure needs to be built, right? And that infrastructure needs to extend from the data centers to the cars in order to allow that connectivity that the applications can be built on top, right? And that's what, I guess ARM and AWS and the other Sophie members are kind of working against.
Yeah, there are multiple ways to interpret that, of course. So in AWS, we frequently talk about a cloud to edge continuum. When with edge, by the way, we intend the vehicle edge, right? So edge can be the cloud edge. So we have things like wavelength and other stuff that stay at the periphery, right? It's close to the thing. But here we're really talking about vehicle edge, the embedded system inside the car. And to do so, again, you need we gave a very nice demonstration about something like this at CES this year to a Sophie demo. Essentially was orchestrating a container down to the vehicle edge. So it was doing development and testing of the container, everything on Sophie and enabled through Sophie, right? So in cloud first, you do all the work there. And then when you're done, you just orchestrate this container down to the car, right? So this is the way we typically do things in cloud. You orchestrate the application. So in that, we created a continuum, a unique control plane, if you think about it, from the cloud to the embedded edge. And that's the mechanism. Why is this possible? It's facilitated for sure by the fact that, for example, we have ARM all along the control plane. So we have ARM64 processors in cloud, ARM64 processors. That's the most diffused architecture in cars nowadays, right? And that helps, right? We call this environmental parity. And we worked a lot with our partners from ARM on this concept in the last 2 years to creating cloud conditions to, let's say, run the same software that runs inside cars. And on the other side, we're working with Sophie to create the conditions to deploy cloud native methodologies inside vehicles, preserving functional safety, real time, and other automotive properties. It's like having these two worlds really to start to work closely together, right? And that's exactly what we did in the last 2 years, and we're still doing it.
So does that mean that, like, I as a application software developer that will need to develop application that will run in a car can actually go build that application and then go through the whole CI/CD pipeline and go through, like, let's say functional safety and whatever not without deploying this application to the hardware in the car? So just use the cloud, and then perhaps once all the check marks are there, migrate that application to the edge with the same guarantees, right? Is that
Yes, that's more
Wow.
or less what it is. It's essentially what we like to call it is a cloud first, cloud native approach to automotive software development, where essentially you use a perfectly abstracted environment that is the cloud, where we have again almost pure implementation of ARM64 accelerators and
Nice.
everything that can be accessed through open standards, right? Like OCI containers, OpenGL, OpenCL, all this kind of open standards where possible. You do most in the initial development there, and only later on you deploy on a specific hardware to continue the
Mhm.
verification, validation, and testing. But the problem nowadays is that it's exactly the opposite. Most frequently, you need to wait for an hardware to come in to start the development. But first, we are in a chip shortage phase. Second, it's wrong anyway as an approach. You never start from a specific hardware to develop an
Yeah.
application. Otherwise, you will never create an ecosystem of developers around it. You need to refer to a standardized environment where thousands of developers can access in a click, right? It's exactly what happens with cloud. You have an AWS account, you can start to work on automotive software for your cars. It's simple like that, right? And it should be
Nice.
simple like that.
But what about like specialized SoCs? So for example, I think we talked about this, like you have SoC that has a certain GPU, or an SoC that is actually driving the display or something like that. So
Mhm.
how those cases are handled then in that scenarios?
So those cases are handled through, that's why we define the environmental parity levels, right?
Hmm.
So one level of is the instruction set. And
Hmm.
if you are just developing CPU code that runs, on ARM or another architecture, but we use ARM, it's you just that's instruction set parity. So whatever works there will work on another ARM64 on another ARM architecture, especially if it is system ready, right? And that's the point, and that's the reason why, for example, now we have AMIs, so operating systems and libraries that we can run in cloud that were never run before, like QNX, so or VxWorks or Ubuntu Real Time, right? So things that were typically in the domain of embedded, right,
Hmm.
and only running there now can run in cloud because we are leveraging this instruction set parity with the embedded target, and it's pretty phenomenal if you if you ask me, because it's for an embedded developer, it's exactly the same experience. You SSH in
Yes.
one of our instances that is running again QNX, and it's not different. You use your ID of choice as you have your evaluation kit on the desk, leveraging just this. So it's just very helpful. When we go through specific components, like for example, we want to go from an ARM64 to a Cortex, for example, M, Cortex A, Cortex R, so specific CPU implementation. And for reference, in our data
Hmm.
center, we have Neoverse, right? So the ARM IP that we use in Graviton is called Neoverse, right? So when you want to do that, we do something called ARM introduced this nice technology, and we use it. It's called we call it hybrid emulation, because
Hmm.
essentially it's a way to execute the common instruction set almost natively on the metal, and just emulating the extended instructions that are entering when you have, let's say, the CPU core. And then you go to another level. When you want to emulate specific components like ISPs, DSPs, or other stuff, you do that in cloud through emulation that can be accelerated or not. For example, in the cloud, we have FPGA instances that can nicely host ISPs or other functionality like this ones, if you need to accelerate the compute, or use the real hardware. we never say that you have to exclude the usage of hardware. In fact, you should always very carefully calculate the trade-off of implementing a high fidelity emulation of your hardware in cloud versus using the real hardware.
Hmm.
And this is a big learning we had in the last year, especially if the system is complex, so it has multiple cores, and and you need to run software in there. Emulation is not probably the most efficient thing to do. virtualization is the right thing to do, right? Not emulation. When the system is contained, well-defined, small, microcontroller-based, classic AutoSAR thing, yes, emulation can be efficient, but it's always a trade-off compute. I don't know, Robert, if you have other elements to add on this.
Yeah, so what's interesting, I mean, one of the real benefits here is if you think about how the length of time it takes to design a new car and the electronics and the software that goes into it, especially as it gets more complex, it might well be that the actual SoC that's going into your vehicle isn't available yet. It's still being designed. You know what it looks like, but it's not available, so you can't run real hardware. So the closer you can get to that SoC running in the cloud, actually gives you the opportunity to develop. I'm back to my shift left again. It allows you to develop a lot of your software early on while you're also designing and having the SoC vendors design the next generation of devices. And that's where using things like these virtual hardware platforms or digital twins in the cloud actually allow you to get these different levels of fidelity depending on what you want your software to do. And then as soon as your SoC is ready, you know you can use the SOFI architecture to then basically orchestrate that down to the SoC itself.
Yeah, that sounds pretty cool. I think we are running out of time. This is a really interesting topic. I think we should have more sessions just to talk about this. It's a pretty cool topic. But that being said, I know that you guys, I know AWS, we will be on Embedded World in Nuremberg. But I think, Robert, you also mentioned that you will be there as well, or your team.
Yes, we will be there. Both IoT and automotive groups will be at Embedded World. We will have a SOFI demo on our booth, and I know there's a SOFI demo on the AWS booth. We're also hosting a SOFI reception in Nuremberg. So if you want to know more about SOFI, go to sofi.io. I think you dropped that into the comments, and you'll see the reception. Then you can just sign up and come along. It'd be great to talk to you about everything that we do with SOFI and how you can get involved.
Yes, that's pretty cool. I know that Dan, you will have a session in our Embedded World live streams, right?
Yes, actually, I think I will have a session covering SOFI in the live streams that we'll be hosting at Embedded World live in the AWS booth. Yeah. So I forget which day that is.
Yeah,
but,
it's a second day. Yeah.
Okay, second day. Yeah, so that'll be a lot of fun to talk through that. But yeah, come visit us at the AWS booth, and if you can't make it, join the live stream that we will be broadcasting every day at Embedded World.
Excellent. Anything else you guys want to add? Stefano,
no, I would thank you so much for having us.
Yeah,
no, it's a pleasure. Yeah.
Yeah, it's been great. And anybody wants to learn more about SOFI, just go to the SOFI website. There's a ton of content on there now, and or contact Steph or myself, and we're happy to tell you all about it. But again, thanks a lot for the invite to come along today. It's been fantastic.
No, excellent. This is a really cool topic. I think we can talk for days. So maybe, after Embedded World, we schedule something else again, just to cover some of the topics. I think there are many. So but it was a pleasure talking to you guys.
Yeah, I think it would be nice, Nenad, to have something about our open source initiatives, right? Like AGL and Yocto, and how all of that mixes up nicely.
Yes. Actually, this is a good thing. Is like we talked about, SOFI high level applications, but there is this kind of like underlying software with the building out the operating system and all that stuff that everything builds on top. So definitely that is on our to-do list. And we also have a session on Embedded World with AGL, so that we can, we will be talking about that as well. So thanks for pointing that out.
And Nenad, you will be at the Automotive Grade Linux booth at Embedded World as well, showing a demo, right?
Yes, correct. There will be a demo as well.
And we will have a demo at the Yocto booth as well.
Correct.
Our Eva ARM platform running part of SOFI. So again,
Yes, the evil. Yeah, excellent. This is, yeah, we will be all over the place, it seems.
Yeah, you can't miss us at Embedded World.
Yes. Excellent. Okay, guys. Once again, thanks a lot for joining. And I guess we will see each other in a better world. But for our listeners, we have this every Wednesday at the same time. So feel free to tune in, join our next sessions. And with that, bye, everybody.
Bye bye.
Bye bye.
Thank you.